Today we're going to learn about multiplying integers. The order of the integers is really important. So for the first factor is the action and how many groups that you have. And we are going to be changing the numbers so that they're a little bit smaller for you to draw. So if the first factor is positive, that means that you are putting in groups. If it's negative, that means you're removing groups. And if you're removing groups, a lot of times that means that we need zero pairs. For the second factor, we're looking at how many tiles there are in each group and the type of tile they are. So we are going to change the 6 times 4 to 3 times 4 to make it less work. So the 3 means that you have 3 groups of 4 positive tiles. So we are going to draw 1, 2, 3, 4, and we're going to put a circle around it to show a group. That's one group, but we need 3. So we're going to add another group and then another group. And that is why 3 times 4 equals 12. 3 times 4 also means that you have a group of 4 and a group of 4 and a group of 4. That's referred to as repeated addition. Looking at the second one, we can change this to be 3 times negative 4 instead. So what that means is that you have 3 groups of 4 negative tiles each. So when we draw our first group, we're going to have a negative tile and another one, and then we're going to count until we have 4. And then we're going to circle it to show a group. So because we need 3 of those groups total, that means we're going to need to add 2 more groups. And that's why 3 times negative 4 equals 12. If you have an expression that says 3 times negative 4, and that means 3 groups of negative 4, that means we have negative 4 and another negative 4 and another negative 4. Looking at the next one, we have negative 2 times negative 3, and we can leave that one the way it is. What this means is that we need to remove 2 groups of 3 negative tiles. So right now, if we look at our mat, there's nothing there, which means we're going to need 0 pairs. So that's one group of 0 pairs, but we need to remove 2 groups, which means we're going to need another set of negative tiles with the 0 pairs. So if we need to remove 2 groups of 3 negative tiles, we're going to cross out these ones and then these ones here, which is why negative 2 times negative 3 is a positive 6. If we remove everything that's negative, everything that we have left is positive. So negative 2 times negative 3 is the same thing as an addition expression that would look like this. So you'll actually notice that we have subtraction. The way you read that is remove, and this means remove, and the negative 3s refer to the type of tile. Example number 4 says negative 2 times 3. This means that we need to remove 2 groups of 3 positive tiles. Now would be a good time to hit pause to try this one on your own. Well, how did it go? How does your picture look? If we remove 2 groups of 3 positive tiles, all we're left with are the negative tiles. So negative 2 times 3 gives you negative 6. So when we need to write an expression out of this, it's going to be a subtraction expression that we read remove 3, remove 3. Why don't you go ahead and try number 5 on your own? Another good time to hit pause. Okay, let's see how you did. 2 times negative 3 means we're going to be putting in 2 groups of 3 negative tiles. So we always like it when the first factor is positive because it's honestly less work to do. So we have our one group of 3 negative tiles and we have another group of 3 negative tiles, which is why 2 times negative 3 is negative 6. Since that first factor is positive, that means we're going to have an addition statement because we're putting in a group of negative 3 and we're putting in another group of negative 3. So let's take a look just at not modeling and what the equivalent expressions are. But we're going to change the numbers so that you have less work to do. So it says, how could you write an expression equivalent to negative 4 times 5 as an addition or subtraction expression? So what this actually means is to remove 4 groups of 5. So we remove 5, remove 5, remove 5, remove 5. Let's take a look at number 7. It says, how could you write an expression equivalent to 6 times negative 5 as an addition or subtraction expression? When it says or, you need to be careful to make sure you're picking the right one. So we're going to change this to 4 times negative 5 to make it less work to do. So this means we're going to put in 4 groups of negative 5. So the way that's going to look is we're putting in negative 5, and we're putting in another negative 5, and another one, and then our fourth one comes right here. Number 8 is probably the trickiest out of all of them because we've got double negatives. So it says, how could you write an expression equivalent to negative 2 times negative 3 as addition or subtraction? Well, this means to remove 2 groups of negative 3. So this means we have remove negative 3, remove negative 3. Now we're going to have the problem without all the scaffolding. It says to draw a chip tile model for each multiplication. Then we're going to rewrite as an addition or subtraction expression. So looking at A, it says 3 times 4, which means 3 groups of 4 positive tiles. Or you could just write 4 positives. So we have group number 1, group number 2, and group number 3. That takes care of the model part. Now we need to know if it's an addition or a subtraction expression. Because the lead term is positive, that means we're going to have an addition expression. So for the expression, we will have 4 plus 4 plus 4. Don't forget the answer part. The answer on this would be 12. So go ahead and try BC D we're going to change to -4 times -1, E and F, and then check your answers against the key on line. That's it.